Again, guys, let's do section 4.8. 4.8 consists of rational exponents and radical notation, okay? Rational exponents and radical notation. We should remember this, that x to the 1 over n is the nth root of x, okay? X to the 1 over n is the nth root of x. Example, x to the 1/2 equals to the square root of x. X to the 1/3 is what? The cube root of x. That's what that says. 16. No, let me not say 16. Watch this. 8 to the 1/3 is the cube root of 8, which is 2. Okay, so that's a rational exponent. A rational exponent can be expressed as a radical. And that's what section 4.8 is doing. Okay? Section 4.8. Okay? Here's an example. Watch this. Consider the following. Watch this. 16 to the 3/4. Okay? Note that this denominator is the index in the radical expression. The index. So this denominator is the index in the radical expression. And this numerator is the power. So watch this. This denominator tells me that we have the 4th root of 16. And you see this numerator in the power? That's the power. Always. We always take care of the root first. So let me take care of the 4th root of 16 and then raise the power. And so therefore the 4th root of 16 is what? 2 to the 3rd, which is 8. Okay? Shall we do it again? Here's another one. Let's say 64 to the 5/3. You see this denominator? This denominator is the root, the index. You see this numerator? That's the power. So watch this. This becomes the index, the cube root. This goes there, of 64. And this becomes the power to the 5th power. Okay. So therefore, what is the cube root of 64? The cube root of 64. What is that? That's 4. 4. To the 5th power. So just multiply 4 times 4 times 4 times 4 times 4. And you get an answer. Okay? If these are a negative, no problem. Watch this. Negative 125 raised to the negative 4/3. Okay? Don't forget, this is the root and this is the power. But before we make this into a radical expression, I better make this negative power positive by taking the reciprocal. So take the reciprocal. 1 over negative 125 to the 4/3. Note, when you take the reciprocal, this power becomes positive. That did not change this base. The base stays negative. And now I'm gonna make this the index, which is the root, and the power. And that's gonna go in the denominator. So therefore this is 1 over the cube root of what? Of negative 125 raised to the what? 4th power. That's a 4, okay? 4th power. So therefore this becomes what? 1 over what is the cube root of negative 125? Negative 5. That's a negative 5 to the 4th power. What's negative 5 times negative 5 times negative 5 times negative 5? Isn't that 625? 1 over 625. Let me get my calculator, guys, okay? Okay. And so I'm gonna do 4 raised to the 5th power. This is 1024, and negative 5 to the 5th power, to the 4th power, let's say 5 to the 4th, okay? 625, so that's right, okay? All right, very good. That's what section 4.8 is doing, okay? In addition to that, section 4.8, it's solving radical equations, okay? So let's solve radical equations. So here is a radical equation. Try this one. Try the square root of 2x plus 5 minus 2 equals 1. Okay? We're going to solve this. To solve this, this is a radical equation. To solve this, we're going to isolate the radical. Get this by itself. To get this by itself, I'm going to add 2 to both sides. So the square root of 2x plus 5 equals 2, 3. Now let me square both sides. Because this is, the index is 2, so I square both sides to get rid of this radical. So square this side, and I get 2x plus 5. And I square this side, and I get 9. Subtract. Subtract 5 from both sides. So 2x equals to 9 minus 5, which is 4. Divide by 2, so that x equals 2. You better check just to make sure that this is not extraneous or basura, as I called it earlier. Okay, so check. So the square root of, what's 2 times 2? 4 plus 5, 9. The square root of 9 minus 2, is that equal to 1? Well, the square root of 9 is 3. Minus 2 equals 1. Check. Yes. That's the solution to this. What's the solution? Solution is 2. Okay. Here is another one. Solving here. I'll give you this one. Let me find, yeah, there's one right there, okay? I would try this one. Try, for example, try the square root of x plus 1 plus 3 equals to the square root of 3x plus 4. Okay. So the first step is to isolate a radical. Isolate one of them. We're lucky because this one is already isolated. Okay? Now, if you square both sides, this radical is going to go away because it's isolated. This radical is not going to go away because it's not isolated because of the 3. So this radical is not by itself. This radical is. I'm going to square both sides. Okay? When I square this side, watch this. I'm going to square and I'm going to square this one. Watch what happens when we square both sides. Watch this. I'm going to show you how to work. You square this, you get the square root of 3x plus 4 times the square root of 3x plus 4. You square this, you get the square root of x plus 1 plus 3 times the square root of x plus 1 plus 3. Okay? I'm showing you all the work. When you multiply this times this, you get the square root of 3x plus 4 squared, and that's how we get 3x plus 4. Note, I square this side, the radical goes away. Watch what happens. When I square this side, the radical is not going to go away. Let's FOIL. First, outer, inner, last. FOIL. The square root of x plus 1 times the square root of x plus 1 is x plus 1. Okay. Outer. The square root of x plus 1 times 3 is plus 3, the square root of x plus 1. Okay. Inner. That's 3. 3 times that is plus 3, the square root of x plus 1. Last, 3 times 3 plus 9. Okay. And this is 3x plus 4. See? You see this radical? It didn't go away. It did not go away because it's being added to 3. It's still there, look. So that's why when you square a radical that's not isolated, that means it's being added or subtracted from a constant, the radical is not going to go away, as in this case. But now we're going to combine this. All right. So this is x. 1 plus 9 is 10. Combine those two. Plus 6 times the square root of x plus 1 equals 3x plus 4. Okay. All right. So now we're going to isolate this radical. To solve, If we isolate it and we square both sides, the radical is going to go away. All right. So let's isolate it. 6 times x, the square root of x plus 1. And now, what is 3x minus x? That's 2x. And what is 4 minus this 10? What's 4 minus 10? Minus 6. Okay. Note, at this point, this radical is being multiplied. If you square both sides now, this radical is going to go away because that's multiplication. Okay. You can divide both sides by 6, but then you're going to have fractions. So you might as well just right now square both sides. So square this side. And square this side. Okay, when you square this side, let's square the 6. That's 36. Okay, square this side, square this, and you get x plus 1. When you square this, you FOIL. That's 2x times 2x. That's 4x squared. FOIL. That's 2x times negative 6. That's negative 12x. That's outer. What about inner? Negative 12x. What about last? Negative 6 times negative 6 plus 36. Okay. You write this twice and then you FOIL. Okay. All right. Very good. We're going to solve the equation. Okay, distribute. So this is 36x plus 36 equals to 4x squared minus 24x plus 36. Okay, lucky for us, this 36 cancels this one. Okay, they cancel each other. And I'm gonna bring this to the right. So let me go here. So 0 equals to 4x squared. And what is negative 24x minus 36x? Okay, is that negative 60x? I think so. Bringing this to the right, negative 24x minus 36x is negative 60x, and that equals to 0. Factor 0 equals to, take out a 4, 4x times x minus 15 equals to 0. Okay, so now we say 4x equal to 0 or x minus 15 equal to 0. So x equals 0 or x equals to 15. You better check. You better check, okay? So check. Plug in 0 there. Check x equals 0. Plug in 0 there. The square root of 1 plus 3 equals, plug in 0 there, the square root of 4. I'm checking x equals 0. Check. X equals 0. Is that a true statement? False. It's not a true statement. Because this is 1 plus 3, that's 4. And 4 equals to, what is the square root of 4? 2. 4 does not equal to 2. So this is false. So therefore, this is not a solution to the original problem. It's extraneous. What I call basura. Check this one. Check x equals to 15. What's 15 plus 1? 16. That's the square root of 16. Plus 3 equals to, What's 3 times 16? Is that 48? 3 times 15, I'm sorry. 3 times 15, that's 45. 45 plus 4. 49. What is the square root of 16? 4 plus 3. What is the square root of 49? 7. True. False. So therefore, this is not a this 0 is not a solution to the original problem because we got a false statement, and this 15 is a solution to the original problem because we got a true statement. So therefore, the solution to this problem, solution that's the solution. Okay, I suppose I could do one more problem from this section, and let me see if I see any. I would do this. Sure, why not? I would do this problem. Okay. Consider this next problem, guys. This is the last problem for this section. Okay. Consider this one. Consider, what should I give you? What should I give you? I'll give you that one. Yep. Okay, I'll give you that one. 6x to the negative 2/3 minus 13x to the negative 1/3 minus 5 equals to 0. Okay, can you see it? Let me see if I can see from the camera. Yeah. Okay. So, guys, here's what you need to do for this one. This one is this is a weird. It's a weird equation. So here's what you do. The best way to do this problem is to make a wish. You wish that this problem was quadratic. Make a wish. What's your wish? That this is quadratic. Okay? That's your wish. So you make it quadratic using a different variable. Keep the same coefficient. Watch this. Make a wish. You wish that this was 6y squared minus 13y minus 5 equals 0. That's what you wish. You make a wish that this was quadratic. Note, I keep the same coefficients, and you just make it quadratic because that's your wish. Excuse me. In order for your wish to come true, go to the middle term and make this variable y equals to that. In order for wish to come true. What do? Go to the middle term. By the way, you have to have it in descending order, okay? Actually, okay. All right, just continue. Go to the middle term and say, let y equals to x to the negative 1/3. Okay? All right. Now, if y equals to negative 1/3 and if y squared equals to x to the negative 2/3, you're in business. So square this and square this. If I get this to equal to that, we're in business, and if we solve this equation, we're solving that one. But this y squared needs to be x to the negative 2/3. So square this. Square this. And square this. When you multiply 2 times negative 1, you get negative 2/3. So you're in business. Good. Now, because this y squared equals to x to the negative 2/3, y squared equals x to the negative 2/3, we're in business. I'm going to factor my wish. Let's factor our wish, okay? Factor. Okay, no problem. We can do that. I'm going to say 3y times 2y. Okay. And I'm going to say 1 times 5. I know that 3y times 5 is 15y, so therefore I'm going to make this negative and this positive. And I'm going to check my work. 3y times 2y is 6y squared. And then 1 times negative 5 is negative 5. And then outer, what's outer? Outer is negative 15y. Inner is 2y. Negative 15y plus 2y is negative 13y. That's it. We have factored our wish. Now let's solve our wish. Here y equals to negative 1/3, and here y equals to 5/2. Okay. Hey guys, so we started with this weird equation. It's a weird one. We made a wish. Make a wish. You make a quadratic because, hey, we can solve quadratics. We can just make a wish. Let's wish this was quadratic. Okay. So once you make your wish, you go to the middle term and you say, let this variable that you're using equals to this variable from the original problem. And then you check this, that this equals to that. And we did, and it came correct. Now here I am factoring my wish, and I solve my wish. But the original problem has x, and I just solve my wish. I have y. So I have to go back to reality. The reality is that I have to solve for x, not y. So let's go back to reality. Reality. The fact is that y equals to x to the negative 1/3. So this y equals to x to the negative 1/3. This y equals to that. Going back to reality, this y, which is that, which means that x to the negative 1/3, which is y equals to negative 1/3. And right here, x to the negative 1/3 equals to 5/2. Remember how to solve this? Well, let's make this positive first. 1 over x to the 1/3 equals to negative 1/3. 1 over x to the 1/3 equals to 5/2. You can cross multiply if you want to. This times that, okay, and this times that. So multiply this way, x to the 1/3 equals, I'm gonna take this negative, put it there. Negative 1 times 3 is negative 3. Cross multiply, you could do that if you want to. Or you just flip them over, that's another way. Flip it over, okay, flip it over and flip it over. Flip it over, x to the 1/3 equals to 2/5. And here, x equals to the cube root of negative 3. And here, x equals to the cube root of 2/5. Okay, those are the answers. If you want, you can multiply this by 25 and this by 25 because I want to rationalize the denominator, and so we get x equals to the cube root of negative 3, and here x equals to the cube root of 2 times 25 is 50, and the cube root of 5 times 25 is 125, 5. Okay. All right. Ah, I'm sorry guys, I made a mistake. Made a mistake here. This is fine. Now you just square both sides. Cube both sides. Cube both sides. Cube both sides. Cube this and we get x. Cube this and we get negative 27. Cube this and we get x. Cube that and we get 8 over 125. That's it. All right, guys. This is section 4.8. Okay. Thank you very much. Do your homework on 4.7 and 4.8.